Oh, so we're recording. This is our next video. It's called Equations of Lines. It's a water park in Greer, South Carolina that we went to a couple summers ago. And there's all sorts of lines there: horizontal, vertical, intersecting, positive slope, negative slope, and an awful lot of water park fun too. But I'll get on with the math of things. There it is. So when we're talking about equations of lines, the one that you are probably most familiar with is the slope-intercept form of an equation, which is our good friend y equals mx plus b. And the reason we call it the slope-intercept form, of course, is because that is the slope, and that represents the y-intercept. So if we have an equation in slope-intercept form, we can graph it pretty rapidly because, if it's, say, for instance, y equals 1/2 x plus 3, we all know that we go up 1, 2, 3. There's my y-intercept. Okay, and then we go up 1 and over 2. And ooh, that was awful, but pretend. A little better. Little thing I've come to realize is the b sort of tells you where to begin, and the m tells you how to move. So y equals mx plus b, slope-intercept form, one that you're familiar with, probably one that we won't use a whole lot. But anyway, standard form, ax plus by equals c. When we're in this form, it's easy to graph if we have, because we can get our y-intercepts and our x-intercepts pretty easily and then graph from there. I don't know, let me see if I can come up with a quick example of that. 3x plus 2y, sure, equals 6. So to find my x-intercept, let's see if I can't do something great. That might work. Let's see. So to find the x-intercept, I want to find out when y is 0. So, oops, y is gone. 3x plus 0 equals 6. So my y-intercept is, my x-intercept, I'm sorry, is 2. X equals 2. To get the y-intercept, I make x equal to 0, 2y equals 6, 10, y equals 3, bing, bang. To graph that equation, which I can't see anymore, 3x plus 2y equals 6. I know that my x-intercept is 2, 1, 2. My y-intercept is 3. That's there. Draw the line. Okay, you'll have to pretend I'm being too lazy to get out the little line drawing tool, which that is just so much better. Let's get rid of that nasty other line. If I can. Yeah, this is. Forget it. Never mind. You know what you're doing. You've seen standard form before. Moving onward to general form. General form, an awful lot like standard form. Ax plus by plus c equals 0. General form, everything's equal to 0. That's all I've got to say about that. A vertical line has an equation. Okay, those are my x and y axis. There's my vertical line, perfectly vertical. The vertical line has the equation. Basically what happens is its x-coordinate is the same no matter where we are on that particular line. So the equation is x is equal to some constant, whether it be 3 or 5 or 7 or negative 14 or whatever it is. A horizontal line, it's horizontal-ish. So there's my x and my y-axis, there's my horizontal line. For that horizontal line, every single point on the horizontal line has the same y-coordinate, even though it may not look like it. And so horizontal line, y is equal to c, some constant. Okay? This one has a slope equal to 0, and this one we say has no slope or an undefined slope or any number of ways that we can put it. So vertical lines, horizontal lines. Here's the new one, or maybe it's the new one, maybe it's one you've seen before. I hope it is. It's the point-slope equation. Point-slope equation is basically the slope formula, y2 minus y1 over x2 minus x1, rewritten. And the way we rewrite it is, well, we start off with y2 minus y1 equals m times x2 minus x1. and that's just by multiplying both sides by this bottom part. So really the way then it becomes into the standard point slope form, y minus y0 equals m times x minus x0. This is a big one. This is a really easy form to use. We use it a lot. You'll learn to like it, or well, you'll learn to use it, or something. But point slope is the one that's really the easiest to deal with, easiest to write an equation of. We can get from point slope to other forms, but this one is the one that learn to love, learn to use, learn to work with. It's your friend, point slope equation. So, parallel lines and perpendicular lines. I have a funny little cartoon that I was going to insert here, but I don't know if I have. I'll have to show you tomorrow. Remind me, funny cartoon. Let me write that down. Funny in quotes, because we don't all think things are funny. Funny cartoon. Okay, so parallel lines have the same slope. Hopefully that's not a surprise. Hopefully that's not new information. So if we have two lines that are parallel, they have the same slope. Perpendicular lines, slopes are opposite reciprocals. So opposite means they have different signs. One's a plus, one's a minus. It says different signs. Reciprocals means flip it. So if one slope has a 2/3, the perpendicular line negative 3/2. Okay? So, the funny cartoon. I'll do something to make sure that it's there. And that is what we're going to say about that particular little topic right there. So, one problem is going to take all of these pieces, everything that we need to know. Obviously, we're going to work with this a whole bunch more, but we're going to try to find the equation of a line that's perpendicular to the line that contains these points that goes through, that's what that should say, that passes through this point. Or I guess contains would work, but alright, so let's not get into the semantics of how bad a question that really was written and move right to it. So in order to find the equation of a line, we need to know the slope of the line. So in order to find the slope of the line, we've got to use the slope formula. Slope formula, I like to write it down every single time I use it because that way I never ever forget it. So slope goes like this: y2 minus y1, 15 minus 7. x2 minus x1, 6 minus 3. I know you're saying, hey, could we have done 7 minus 15 and 3 minus 6? Of course you could, because it would give you the same thing. They'd both be negative, and it would be just fine. 15 minus 7 is 8. 6 minus 3 is 3. Slope is 8/3. Okay, a fine and wonderful number. We don't need to turn it into something else. Remember, slopes we like improper because it tells us how to rise and run and all that sort of stuff. All right, so now we need an equation, and should say an equation of a line perpendicular. So we know it's going through this point. We know that the slope of the line that we're talking about is 8/3. The perpendicular line is going to have an opposite reciprocal. So this is the slope of my line. The slope of the perpendicular line is going to be negative 3/8. Okay, here's where you see why point slope equation is your friend. Y minus y naught equals m x minus x naught. Okay, y minus, pick one of your y values. Well, the only one you actually have. Never mind. Pick the y value that we're using. Y minus 12 equals my slope, negative 3/8. X minus the corresponding other value, x minus negative 2. And we are just about all done writing this equation out. I'm going to have to extend just a touch. And just to rewrite it as y minus 12 equals negative 3/8 x plus 2. That's it. Done. Fini. That is an equation of a line. That one works perfectly. It's a fine form. We don't need to change the standard form unless it says find the standard form equation or some other form, but it just says find an equation, find the equation, find something that works. Yeah, we could graph this if we really needed to, but that's the point. Perpendicular, opposite reciprocal, slope, things we've done before. True? I think that's the end. By golly, it is. We'll have some work to do with this tomorrow. Oops, yeah, just quick rewind, quick rewind, quick rewind. There we go. I think it's there. Equations of lines. That's about all we're going to say about that today. Where'd we go? So, thanks for listening. Hope you learned something. If you have questions, please feel free to ask them.